Hi, this is Denisa, and in this video I'll be going over how to write a program in Python that will display pi on the screen using an infinite series. Now, I've derived this from a coding challenge on this website called Codebymath, and Codebymath is a really great website that is aimed at teaching people how to write simple computer programs in the context of exploring mathematics, or vice versa, as the website puts it. And it has a repository of great lessons that goes over how to write a bunch of programs starting from the ground up, and it's all in the context of mathematics. Now in this video I'll be doing one of their challenges from their challenges section. It is the first one in how to write a series to find pi. Now, the infinite series, the formula that's used here, I'm not going to talk about the theory surrounding it. I'll only be going over how to express it using Python and code in this video. But if you want to read further about it, there's a Wikipedia article for it. It's called the Leibniz formula. Here you can see it. And this website uses Lua, as you can see, but I'll just be using Python because that's what I'm learning. And Python actually has a library dedicated specifically for mathematical usage, but I'll just be using plain old Python to write a simple program to express a formula. Now, to go about expressing the formula as asked here, I'll be writing it out as it is expressed. So sum is equals to 1 take away minus third plus fifth minus seventh. And I think that's it actually. And then sum, and then it's multiplied by 4. Then let's run it and see. It works out. Okay, so you get this value. Now this is an infinite series to reach the sum of pi. So the thing is that the more terms you add, the more accurate you'll get to the actual pi. So you can see this if we add, let's see, a few more terms. As you can see, it's the denominators go from 3 to 5 to 7. So we'll go to 9. Because it goes up by 2, and you can see that the signs alternate. So minus 11 plus 13 minus 15, and these are all the terms are reciprocals of each term. And as you can see here, it gets closer to the value of pi, but it's not quite 3.14. Now you can go on adding all these terms until you eventually reach a value of pi, and until you reach a value of pi that you might be satisfied with. But obviously we can't go on typing forever. Even up to 100 digits, you won't get to the exact value of pi. So what you can do is you can write a for loop for each of these terms. So for term n in range 1, 100, as the website asks, Codebymath, each term goes up by 2. So in a mathematical sequence, you can express this as 2 multiplied by the term plus 1. So if we go through the values, we go from 1 to 2 to 3, 4, 5, and you multiply each of those by this sequence. So 2 multiplied by 1, 2 plus 3, no, plus 1, 3, 2 multiplied by 2, 4, plus 1, 5, and then 7, 9, and on. And each term is a reciprocal of that output from the mathematical sequence. Now you can see in the formula that the signs for each term actually alternate, and we can handle that by multiplying each term by -1 to the power of the term. So in the first term, 3, you'll have -1 to the power of 1, so that will be minus 3, and then you'll have -1 to the power of 2, which is 1, so multiplying that by 5, you get +5, and then you'll have -7, -3, and all these are reciprocals, by the way, and +9, -11, and so on and on. And then, of course, you'll be adding these to 1. And then you have this multiplied by 4. To make it more readable, you can put the formula for the sign in a separate variable. It's just for really much more readability in a program, because it's really a simple program, not even 10 lines, so you can afford to put it in a separate variable, really. And we can run it and see how it goes. And there you go. Up to 100, much closer to our pi than the maybe 5, 7, 9 terms we put out. You can see it's still not 3.14. Everyone knows those first 2 digits, right? So you can increase the number of terms to get much closer to the value. And still not. Let's see, increase it to 1,000. There, you get 3.14 finally. And then obviously, just the more terms you add, the closer you'll get to the value, the real value of pi. And there you go, really. You can just keep adding those values. And there you go, that's it. How to express the value of pi using Python, deriving the Leibniz formula here. And there you go, really. That's it. Thanks for watching, and be sure to check out all of the other challenges on Codebymath.